This time on Engine Masters, we are living the tunnel ram life and showing you what camshaft lobe separation angle is all about. Whoa. That was the bad one anyway. Me and the Steves love testing engines, and in particular, we love testing camshafts because there's always something to learn, and this time we're going to address one of the most complicated things about camshaft profiles, and it is lobe separation angle, or lobe displacement angle, also called LSA or LDA. First, let me tell you what that's all about, and we'll do it staring at this 440 Mopar camshaft by Comp Cams right here. So the forwardmost lobe on the cam is the exhaust port on this Mopar. It's opening and closing the exhaust valve. The third one back is the intake lobe for opening and closing the intake valve. Look at them and you can see that there is an angle. So if you draw an imaginary center line between the peak lift of both of these lobes, you can see that there is an angle between the two. When you have a tighter lobe separation angle of 106 degrees, the exhaust events all happen later. The intake events all happen sooner. The opposite is true when you spread it out to a wide lobe separation angle. At that point, all of the exhaust intake and closing events happen earlier, and all of the intake happens later. So there's a lot of voodoo that has to do with this, and as a matter of fact, if you have a dual overhead cam engine where you've got one stick that's got the intake lobes and one of them that's got the exhaust, you can move that stuff all over the place independent of each other. We're gonna keep it very simple for this test. We're gonna run 3 different lobe displacement angles, 106 degrees, 112 degrees, and 118 degrees. So what we've got there is 106 is tighter. It's closed up like that. 118 is really wide. It's spread open like that. And so we got Comp Cams to make us 3 separate camshafts that are identical except for the lobe separation angle. They're all mechanical rollers. They all have a duration at 50 of 264 on the intake, 268 on the exhaust. The lift is 660 and 330. That lobe separation angle again is 106, then 112, then 118. So let me talk a little bit about what you can kind of expect from this, which you might not see on the dyno, and that is idle quality. When you take that lobe separation angle and tighten it up, it makes for a lot of valve overlap, which is the period of time that both the intake and the exhaust valve are open at the same time across the end of the exhaust stroke and into the intake stroke. That's what gives a camshaft that really choppy idle. It makes it sound gnarly, but it also reduces idle vacuum and can make drivability difficult. So that is the cost of the tight lobe separation angle. However, it tends to make much beefier mid-range torque. When you widen out that lobe separation angle, you smooth the idle. You get greater vacuum, and that's the reason you see it in a lot of VFI applications. And the other thing that you do with that wide lobe sep is it tends to favor the much higher end of the RPM curve for the camshaft at the sacrifice of mid-range torque. So our plan is to run those 3 camshafts through that 440 Chrysler. And to tell you all about that, the beauty is on duty. Mr. Steve Dulcich!
All right, put me in the Wayback Machine because I actually built this engine 20 years ago, and honestly, it hasn't been apart since then. Let me give you a little detail about the whole combination here. Most of the stuff is really stock passenger car equipment. I've got a stock 1969 block, I've got a stock forged steel crank, and I've got 67 440 heads, which I ported. Now the block is filled with some high-performance parts to add durability and performance. I've got Eagle H-beam rods, I've got Arius pistons, which give me 12.66 to 1 compression with these cylinder heads. The bottom end has a Mylodon stud kit, a Mylodon deep sump pan, and a Mylodon tray. Now, the real beauty of this engine is sitting right here, the glorious Wyand high ram tunnel ramp. I used this engine for all kinds of dyno tests for magazine articles, and one of the things I did was test a 4150 4-barrel combination, a Dominator setup with a single carb, and this, my tunnel ramp. And the tunnel ramp pretty much put everything else to shame. So we're gonna roll this thing into the dyno, With the 106-degree lobe separation angle, we're gonna see what kind of power that makes, and we'll compare it to the other two camshafts. And more importantly for me, I get to see if it still makes the same power it did 20 years ago.
The only thing I know here is that I'm gonna get smarter by the time we're done. I've done this test before, but I think not knowing as much as I know now, so I'm gonna be able to look at more things and think through more camshaft event processes and get smarter.
And have more questions when you're done.
For sure, every single time.
Always the case.
And I'll have way less anxiety when we're done.
Are you still all torqued up?
Dude, yeah.
My favorite part about this episode, he's in charge of the mechanical stuff.
Oh, perfect. Yeah, but he's all freaked out. Every time Dulcich has his own engine on the dyno, he gets all twisted.
Why do you guys like it so much when I'm actually feeling a lot of consternation? I mean, why would that give you pleasure and joy? Seriously, I mean, we're all friends. We've been working together for a long time.
It's just the total reaction, and bringing you back down is really the fun part, telling you that it'll be okay.
I'd actually like to put this in a car now, but Steve, why don't you just put me out of my misery and get this test over with?
That's a good idea.
I can do that.
All right, we're gonna fire it up initially with the camshaft with 106 lobe separation angle. So we're gonna see big horsepower and find out what it makes on the 106. First of all, Dulcich, that's a stout iron head 440.
Yeah, I know, it
It
is
runs pretty good.
Yeah.
All right, here's our power numbers. It made 664.9 at 6,300 RPM, and I'm gonna allow Dulcich to call that 665.
Oh, thanks, buddy.
And 614.1 pound-feet of torque at 5,000 RPM. And I did the math, that's 1.36 pound-feet per cubic inch, which for 452 inches with an iron head is like pretty wowzer.
The iron head part's the most impressive.
Yeah. I mean, the tunnel ram's contributing to that, and so is the 12.6, 6 to 1 compression for sure. But still, to be able to even move the air through that small block head that they installed on 440s is not bad.
Not just iron, but an actual original equipment production iron head.
It's a 67 440 cylinder head.
And Steve
that
put
was all
his
wind
magic
speed.
in. Oh. Boom.
So we're going, this is 106, and we're about ready to go 112. So we're spreading at 6.
Yep.
All right, here we go. Cam swap. Brule's gonna watch, Dulcich is gonna change, and I'm gonna surf Instagram.
You can get that, Troy. You're strong as an ox.
Look at this. This is supposed to be a press fit, but Dulcich honed it so that we can do the swap really quickly. Nice.
All right, it did better than I thought. Because a lot of times when they heat up, they get stuck.
Yeah. A bunch of people have asked me what the point is of this unit right here, which is the Jessel, which is the brand, camshaft belt drive. People have seen this on that other big block that we were running, and on social media they asked me, you know, what's the point of that? Does it make more power? Theoretically, supposedly, the rubber belt instead of the chain transfers less crankshaft harmonic to the camshaft. Does it matter on this? I don't think so, especially at an engine at this level. Maybe if you're running some pro stocker with all kinds of valve spring pressure, it's a different story. In this case, it's super handy for us because you can change camshafts more quickly, and it's got just an adjustable slip in it so that you can degree the camshafts like that. Do you agree with this, Steve?
Absolutely, yeah.
Okay.
The convenient thing from a testing standpoint is a lot of times that's part of the process. We'll swing the camshaft forward and back a couple of degrees to see what the engine actually likes and optimize the tune-up with it.
Yeah, it just makes it super easy on cam timing is the main reason we run them. All right, now you just pull these out and cam out. That's a big time saver. These are good cams to keep too.
Yeah, they are.
Stabbing in the 112-degree lobe sep cam.
All right, that's it. The engine's all back together. We've pulled out the 106-degree lobe separation angle cam, and we went with a 112. That's a big change, but we want to see a big difference. So we're going to take a look at what that does to the power curve.
Well, looking at the peak numbers, we just made 660 horsepower at 6,400 RPM and knocked the guts out of the torque at 587 pound-feet at 5,100.
Really?
Yeah, but this isn't going to be a story about peaks. This is going to be a story about shape of the curve. So let's have a look at the graph.
Boom.
Oh!
Wow.
You would not choose to do that.
No, and that's what I was saying. It's just different motors, but the OEMs do it for idle quality and smooth and low emissions and no overlap and all of that.
You mean OEMs run wide lobe separation angles for all of that?
Racers do it for stuff out here where this engine doesn't run.
Right.
And so all this is, to me, is just a loser.
So I think the other reason that we run them on big blocks is that we're running such a big lobe that when you spread it wide, you've still got overlap.
Well, or less overlap with the larger lobe, right?
Less overlap? No, what I'm saying is
when you spread them out.
Yeah, but obviously if you took the same cam and ran it narrower, but the lobe is so big that when you say it's on a 114, it's still got a ton of overlap compared with what you would do with a smaller lobe.
Yeah.
The smaller the lobe is, the more radical the change is on lobe separation angle, the effect on overlap.
Yeah, no, there's still a lot of overlap with the larger camshafts. But again, most of the time when you're looking at a camshaft that big, and whether it's a big block or a small block, the thing's revving up to 8,000 or 8,500 RPM. You're not trying to take advantage of a 112 or 14 lobe sep at 6,500 or 7,000.
Right.
You're looking for that advantage up higher.
I've been playing in that neighborhood so much recently that I forgot why when you flip through the cam catalogs, all the drag race cams are on a 106 or a 104 or 108. And that's why, because, I mean, we just killed this thing.
Well, even more so when you look at the catalogs, you'll see circle track stuff on 106s and that sort of thing because they want the torque coming out of the corner.
Wow, that's more dramatic than I was hoping for.
No, but that's okay because when I originally built this engine 20 years ago, the lobe sep I went with was 107.
Yeah.
Because I knew it was a production-based cylinder head, and it's a small cross-sectional area, so it's airflow limited at that displacement. Now, if I was doing a 383 with the same head, it might want to go a little bit wider and still be okay and run out the back door at a higher RPM.
Because of the RPM capability?
Yeah, the airflow to displacement, basically.
Okay.
So
I remember about 100 years ago, I remember a 360 cubic inch sprint car guy saying he was putting a 106 lobe sep cam in and that should help it out of the corners. And I just didn't grasp it.
Right.
This sure helps. This is real visual.
It's interesting because when I was completely ignorant of all this stuff, instead of just mostly ignorant about all this stuff, I used to think, I thought because drag race cams for small blocks and stuff, they are on 106 and 108, and they idle really ratty. I thought they were for RPM. It's not. That big overlap actually is for torque.
Mid-range. It comes on the cam.
Mid-range.
When it comes on the cam, which is where things tune together and it just gets that boost in torque right there in the mid-range.
And Comp Cams always does their shelf, not always, most of their shelf cams are on a 110 for a typical street strip engine. And I think that's for a balance between idle quality, because a 106 is ratty and lumpy and messy, and still making some of that mid-range power.
I think a 110 is probably, as far as a compromise, it kind of catches everything.
Okay.
You're not giving it away as like a 112 or 14 and getting very specific, and you're not getting that horrible idle like on a 104 or 106 or something. So a 110 is really a great compromise. But when you get more specific and the application and you learn a little more about this stuff, you start to look for those little small changes that you can make to enhance the performance of your application.
What I'm hearing a lot on this is that, unlike some of the other things that we do with camshafts, that in the world of the engines we deal with is fairly universal. Like you add duration, you add RPM, kind of. You advance the cam, you get more low end. You retard it, you get more high end. Those are like general rules. But what we're doing here with the lobe separation angle seems, based on what you guys are saying, to be more engine specific.
Oh, absolutely.
Yeah. So
and application specific.
Yeah, making it a bigger problem for the average guy to decide what to do, which is why you just default to 110. And this engine's kind of a tweener. It's not a normal street strip engine. It's weird because it has compression and a tunnel ram and a tiny cylinder head that you've improved. So maybe it wasn't the best thing to actually do this test on. Maybe we should have done it on a more typical engine.
You know, I've seen the same test with a 350 or 383 Chevrolet and 10 1/4 to 1 compression. The results are really just very similar. I mean, these characteristics and, like you say, the engines that we typically deal with that's kind of the outcome.
So this is 106, this is 112. Is 110 going to be right between these two?
Yeah.
That's what happens.
Yeah, pretty much. Okay, I think that was the meat of the episode, and now we're going to move on to seeing how much we can actually ruin Dulcich's 440.
How much power can we lose?
With the 118. Let's go make it worse. Another cam swap coming up.
Can we run the cameras backwards and then finish with the,
I know.
with the other cam? What I'm doing here is putting on the push rods. And here's a little tip, because if you just put the push rods in, they'll drop down out of position. But the simple trick here is just to put a little piece of welding rod across the rocker stands, and that'll build them up to just about the perfect height. You can drop the rocker shaft assembly on, and the whole thing is ready to tighten and go. So you don't want to just like ramrod any of the 5 bolts holding the shaft down. That's going to stress the shaft because some valves are open or some rockers are going to be engaged. So you want to just kind of ease it down that way so you can avoid damaging the shaft.
Okay, I think we're done. Ready to go fire it up and find out how much power this camshaft kills. All right, Dulcich, brace yourself for disappointment.
No way, man. It might be the magic cam. The 118 might be the key.
We're going the wrong way on this episode.
I don't think so.
Well, our peak numbers here are once again destroying the torque curve. 575.2 pound-feet of torque at a peak RPM of 5,300. And the horsepower is basically the same, 659.9. Call that 660 at 6,500 RPM, which tells you why you never want to believe when somebody just tells you how much horsepower that their junk makes. Never trust engine masters when they only talk about horsepower, because we're about to show you why that's not the only thing that matters. There's the curve right there with our 118-degree lobe separation angle camshaft. We're going to overlay it with the 112, and there you go. The 112 is in red, and yeah, it's...
See, that's a trend we were talking about. Up here, where the street engines are kind of done, is when the super wide lobe separation angle may actually start to have some advantage.
Well, it did actually raise the RPM at which peak power occurred by a couple hundred RPM.
It did. So you're saying if this was a 327 with a good cylinder head on it and you were going to run it to like 8,500 RPM, this might be the right thing to do?
Yeah, if you didn't care about anything it did below 6,500.
Okay, yeah.
You'd run it from 65 to 85. Yeah, it might be the right thing to do.
Yeah. Okay, now to show you just actually how devastatingly bad this really is, let's compare it to the 106-degree lobe separation angle where we started.
Oh, wow. You'd like that.
So clearly, the blue lines here are the best camshaft with the 106.
Look what it does here, though. With each step of wider lobe sep, it starts to carry a little bit better up here where we're not using it.
Why did it only float the valves or have a valve spring issue with the 106 cam?
I think the springs warmed up after Dulcich leaving the engine sit there for 10 years.
That's possible.
They've rejuvenated themselves.
It's actually possible.
The real meat of the story here is like right off the hit at 3,500 up through peak torque. I mean, it's just free power down there.
Up through peak torque. How about up through peak horsepower?
Well, okay.
It's all the way.
All the way.
All the way. That tight lobe separation angle's a win. And as disappointing as this was to go backwards in the power curve, the average power the whole time, it still taught me something. Because I'm still rolling around in my head the whole concept of like when you would want to pick something that has a really wide lobe separation angle versus when you wouldn't. We haven't talked about idle quality. We haven't talked about if you have EFI and you know, are more comfortable tuning it with a better idle quality, which you get with the wider lobe separation cam.
Idle quality, vacuum signal, all the things that EFI wants. That's part of the reason. Probably part of the reason that we see it in factory camshafts now versus, or in the fuel injection era versus muscle cars, 60s, 70s era stuff.
Well, and also the newer cars have much better cylinder heads than they did back then, which is why they can get away with those camshafts. It really speaks to what makes the LS so good, is that it can be, the combination of a great head and a small cam with a lot of lobe separation.
And then what about runner length, too? How is that going to affect it? You know, that's kind of a question mark still, but I would say the correct lobe separation angle is really specific to your combination and your RPM range.
Absolutely.
I mean, we can't walk away from this and just say, oh, you want a super tight lobe separation in every case.
No, and in fact, there aren't even, this is what I was saying earlier, there isn't a general trend that we can say. Like with duration, you can say you add duration, you increase your RPM at peak horsepower. You know, it pushes the RPM up pretty much universally until you saturate the cylinder head or whatever. But with this, it's really engine specific.
You guys have driven stick shift cars with type lobe set camshafts, right?
Yeah,
right.
And they
aren't they freaking miserable? I mean, it's just like this all the time. So there's a good reason. It's just for drivability.
Wow, that is an eye-opener, though. I mean, this test went too far on the wide. I would have rather seen us go like 102, 106, 112. The 118 is just off the plot.
But I think it's good for demonstration purposes. I mean, I think it shows us what the trends are.
All right. Let's get this baby off the dyno and sum it up, Freiberger.
Let's get this baby off the dyno and get that 106 cam back in it stat.
I know.
Absolutely.
Okay, Steve, with every test, we progressively castrated this thing more and more and more.
Oh, you know how to hurt a guy.
So I want to throw it back to the beginning to give you credit for making 660-something horsepower out of stock iron heads on a 440 with a stock stroke.
Well, thanks for the kudos, Freiberger.
It's really good.
I do appreciate it. I was pretty satisfied with that number.
It was great. I wasn't that satisfied with our camshaft testing results. I always have to scale my comments about these tests down to what I think is the average street strip muscle car guy with an engine like this. In other words, we're not dealing with Formula One or pro stock or even a guy trying to run eights. It's a guy who's got anything from a daily driver to a 9-second muscle car.
Okay.
In that range, I would say pretty much get a camshaft with a 110-degree lobe separation angle, maybe a 108 if you're drag racing.
Right.
If it's a dedicated drag race car and it's only going to run up to about 6,500 RPM, get the 106.
Right.
I think that there's no real call for getting anything really wide, like a 114 or something, unless you're dealing with an LS engine with a fantastic cylinder head, or unless maybe you want really great idle quality with EFI.
Yeah, or if you've got a very, very high performance car or boat or something where you're revving it out to 7 or 8 grand.
Oh, that's when you would use a wider one, if it was really above 7 grand.
Another validation besides the horsepower, when I first put this together, and I used a comp roller cam back then, which is quite similar to what we tested today, I picked 107.
Oh, did you?
Yeah.
Yeah.
And it made almost the same power as our 106. So there you go.
So there you go. I didn't learn a lot from the data that we actually saw here because we just kept on killing power, but I think it was definitely representative of the fact that you can go way wrong with lobe separation angle, and if you've got a question, basically pick the camshaft out of the catalog, look at the description. They've done a pretty good job of keeping you out of trouble. Comp cams for the win, and the Dulcich 440 tunnel ram motor for the win. How cool is this guy? I'm gonna see how happy you are when this thing makes like big power.
I built this 20 years ago, Freiberger. Do you realize that?
It didn't break sitting in your garage.
Yeah, that's true. I haven't run it in 10.
Might have rusted.
Yeah.
Yeah. Well, we've already tuned it up a little bit, so we know the 440 runs. So you should have seen him off camera like, 3 hours ago. It was just like, one cigarette off the end of another, one beer off the end of another.
I guess it would be horrible for me to admit that I was enjoying it just this much.
I know.